Hey guys, Mr. T here. This is another video. This one is on the critical path, or finding the critical path. Now, we haven't looked at precedent networks with edges on them yet, but precedence networks with edge weighting, so these numbers next to the edges in addition to their labels. The weighting represents the timing or duration of tasks. They all have a critical path through them, which determines the overall length of time required to complete the project. The critical path is the longest path, so the highest total weight, therefore the longest duration, through the precedence network from start to finish. You can see why they're going to be the critical paths, and they determine the overall length of time required to complete the project once we do this example. Tasks on the critical path are known as critical tasks. So let's have a look at the following example, this precedence network that's provided. Given that the edge weights represent task duration in seconds, let's identify the critical path through the network and therefore the critical tasks. So, this is a pretty simplistic network. There is some variation at the start of it. There's going to be two paths because we have this split at the start. So you can go A, B, E, F, G, or C, D, E, F, G. So let's write those to start off with. Two possible paths, we need to work out which is the critical one. It's going to be the longest, so A to B to E to F to G, or C to D and then the same again to E to F to G. So we use the weights to determine how long the paths would take, and the longest is going to be the critical path. 15 plus 10, 25, plus 10, 35, plus 15, not plus, 35, 50, plus 10, is 60 seconds. Okay. The other path, let's see, 20 plus 100, we're at 120 already, plus 10, 130, plus 15, 145, plus 10, 155. So it's clearly that one is a longer path than the other. Therefore, C, D, E, F, G is the critical path. These are the critical tasks because they form the critical path. So let's have a think about why that is the critical path, and have a think about what this network represents. So overall, G is the final task to be done. That's the first thing to think about. E is a prerequisite of G. Why? Because it's a prerequisite of F, F is a prerequisite of G, therefore E is a prerequisite of G. Now, B and D are both prerequisites of E. They have to happen, they have to occur before E can proceed. So, must be completed for E to occur. And that is this point here is showing why the C, D, E, F, G path is the critical path. Because as C and D take how many seconds to complete? 120 for them to pass by. Secs to complete. It doesn't matter how fast you do A and B. You could do them in 5 and 5. You can do them in 1 and 1. It doesn't matter that you do these faster. 20 and 100 need to pass by before E can proceed, because D is a prerequisite to E. Therefore, they're the critical path. So that's just an overview of the thinking behind what forms a critical path. It doesn't matter about A and B. It doesn't matter that A and B finish faster. E only proceeds once D is done, and that occurs 120 seconds into the project, ignoring the fact that 25 seconds into the project, B allows E to proceed. D won't allow it until 120 seconds has passed. Therefore, C, D, E, F, G is the critical path, and they are the critical tasks. So hopefully that helps you out in understanding what is meant by a critical path and why it's known as the critical path. It determines how long the project goes for, because it's the longest duration path for everything to proceed correctly and get to the finish. Alright, so I will see you in the next video.